Alright, hit the button. DraftScience. Yeah, don't take this one too serious. Anyway, doing thinking. You know, once it gets in your head, you can't get it out. Yeah, I thought I'd just try to... It's very hard to conceptualize, right? So you're saying, okay, there's a field of things all moving the speed of light, and from the perspective of one of those things, you have to kind of understand that direction is sort of irrelevant. I mean, any way they look, it looks the same. The field is exactly the same. It doesn't matter whether they go left or they go right. It's all the same amount of stuff for them to interact with, because everything else is going the speed of light. And they can't, their orientation is just not relevant. It just doesn't matter whether they go in a straight line in one direction, or they go crooked line, or they do, doesn't matter. It just doesn't matter. Their interactions will be essentially the same. They can't change how much they're going to interact. And so when something's moving something, see, the key word there is a something. What's a something? When a bunch of these things are all moving in one direction, it has the illusion that it might mean something, but it really doesn't mean anything. Because as individuals, they're just going to do the same thing they'd be doing if they were all going in different directions. There's nothing fundamentally different in going one direction or going in many directions. It just doesn't matter, you know. So I mean, it's just hard to conceptualize this idea that you can't escape the things behind you when everything's going the same speed. You just can't decide I'm going to go in a direction and escape the stuff that's in that direction behind me. You just really can't do that. You can't escape the pressure, so to speak, because you're just one fish. And that's the problem, is it's just visually, it's hard to imagine that circumstance because it doesn't look like anything we see in the world. So anyway, just thought I'd throw that in, just because I know it's a little, this idea of velocity being meaningless, you know, from the perspective of the universe, it doesn't mean anything because it can't mean anything, because everything's already moving the speed of light, and it's just a pattern that's moving through the medium. And so the medium doesn't care what your pattern is. It just cares how fast you're going and that you obey the rules that you can only move the speed of light. But it just doesn't care whether you're look like you're moving in a circle or look like you're doing something. What you're really doing is your individual fish moving 1 parsec of space, you know, per unit of time. And that's all you're doing, just like all the other fish. Okay. So yeah, just like I said, it's a visual problem, but it's all, you know, drawing good models of this stuff is always good. It's going to be difficult. So anyway, I thought I would do some of the internals of what an atom might be doing, which is just going to make things worse. You know, it just gets, you know, because there's lots of subtle. It's always so hard to put it back into that model of just the individual fish, because you're dealing with something that's obviously much bigger than that. An atom would have, you know, 1 billion more. I don't know how many photons of energy are in a single atom. You know, it's a lot of these little gravitons or whatever you want to call them. So anyway, I just thought I would deal with the what creates this differential in pressure in the ability of the universe to affect a atom, and what keeps it together and all that kind of stuff. So I just thought I'd mess with the parts of it. So anyway, so let's mess with it a little bit. Let's see where it goes. So you have, let's just go with the real standard, I mean the real old crude standard kind of idea of what an atom is. And so you have a neutron and you have a proton, and then you have the electron. Alright, now this gravity theory is basically a shadow theory. So it's basically saying that when something is in line with something else, everything in line with that may be blocked from its view. So you would argue that the proton is blocking something that is making the pressure from this side greater, which is keeping the electron associated to the proton. And then I'm going to argue that the neutron is creating an opposite force that's keeping the electron away. So the electron can't crash into the proton. So it just keeps a balance between these three entities, and that the neutron and the proton end up being attracted to each other, and but they don't also combine. So anyway, the idea is that that things have a sensitivity, and so there's the external force would have a mixed range of type. So it would say if there was say if we just use a range of 1 to 6, it would contain a mixture of 1 to 6s. And the idea would be that electrons could be just sensitive to 3 to 6, and that 4 to 6, and that they would create as a response just a certain other type. So that would be basically the idea of polarization, is that you have the same thing, but you just have it oriented in a different way, which means something can be affected by it or not affected by it because it's a specific type of the thing. So that's all polarization is a shape to something that just makes it detectable or filterable. Yeah, that's a good word, filterable. So the basic idea is that this. So see, we're going back to the little fish thing, but say we got to figure that each one of these entities is a mechanism in itself, a big blob of little stuff going around each other, and that this little graviton comes in, is influenced in the sense that it does something and it leaves something else. So it goes in one way and it leaves, imparting a change in direction. So what it did is it lost some direction in this way and it gave this some direction in this way. And that would be the idea of this exchange of a tendency to move in a direction or an orientation. But there's a lot of ways you can play with that mechanism. But the idea would be is that there's it can't. It could be that it's much more kinetic, that it just plows into the thing, smashes into it, and bounces off, in like an opposite direction. That certainly could be a possibility also. Because it's not like it has to. It's like it could roll it or spin it. It might be the best way to say. So it adds a spin to it. You could even argue that it sticks for a little while, tends to spin it in a direction, and then flies off and leaves behind a spin. And spins would be important in some other way, especially if things are coming in actually contact with each other. Spin would be very important because they would impart their spin on each other. But anyway, let's not get too deep into this. So let's say the proton, we know it has to, and the electron are attracted to each other. So let's say when that protons are they don't see, there's a certain polarization that they're invisible to. So let's just say it's the low numbers. So it's invisible to 1 to 3s. Okay, but 4 to 6s will push it. Alright, so that's the proton standard. So when some gravity comes in, a little graviton plows into a proton and leaves, it always will leave in a certain polarization. So let's just say it leaves as a 6. So it goes to the high end 6. And so then we can just say that, well, that'll tell us that because there's an attractive force here, that 6s must be invisible to electrons. So 4 to 6 is invisible. And let's find a way to say invisible. Invisible will be a little star. And so what do we say? That yeah, these are invisible here. And yeah, there's got to be a better way, right? Well, we'll just do this for now. So invisible has the little blob after it. So anyway, so 6s, so electrons are invisible to the 4 to 6s, and they will they'll be affected, pushed away by a 1 to 3. So a 1 to 3 is the hard one, and the 4 to 6 is the weak one. So maybe we'll just circle the ones that are hard. So these are the ones that will affect it. So now that sort of works out, and so let's just say that when an electron produces a photon, or when something goes through it has to create something that's invisible to protons. That would connect those two together. So we know that protons are invisible to 1 to 3s, so we know that electrons are producing 3s. So 3s come out. And so you could sort of see that if a graviton goes in here, it comes out a 3. Protons are invisible to 3s, so the external force becomes more potent in terms of pushing those two together. Now the neutron does the thing in the middle. So that's what makes it possible for it to repel electrons and yet attract protons. So it's got to be producing a 3, because it's got to be hitting what's repulsive to electrons. So it's producing 3s, but it's got to be attracted to the proton, so it's got to be personally sensitive to, it's got to be invisible to what the protons are creating, which is 6s. So it's invisible to the two extremes. So it's invisible to 1s and 6s. Those are its invisibles, and then the things in the blob, the mess in the middle, is what it is affected by. Or one could argue that all it is, well, that would be good enough, I think. So the middle stuff, the 2 to 5s, will push it. So it's invisible to those. So the 3 would be in the 2 to 5 range. So obviously it's going to be repelled by the electron, and it will be attracted to the proton. So it's repulsive to the electron. The electrons are repulsive to it. The proton's attracted to the electron, and the electron's attracted to the proton. And so that creates a balance between the 3 entities. Obviously, following all this is not going to be that easy, but again, it's this idea of a shadow effect, like I said, and the fact that these two would be just exchanging their happy stuff. So that would be a very strong bond, and there's got to be a reason that they're not combining or some other thing. So there's got to be some other circumstance that keeps them from doing that. Now I'm just theorizing for the sake of, for the sake of it. I was just thinking about the idea of this. What neutrons end up being is, you can end up creating a filter by depending on which way these two are oriented, because when you think about what comes in this way and what the effect is in terms of what comes out this way, and vice versa, and the circumstance would kind of be created where you could imagine that this could almost be a, when these are lined up the right way, something could be quite invisible to certain forces, or even gravity itself. Oriented the right way, it ends up converting, it ends up being invisible and then producing a product that the next thing is also invisible to. So it's like double invisibility kind of a thing. So in this direction, it would be invisible to most of the, because they have to be polarized, and the regular common mix probably isn't polarized, significantly. So it's invisible to a no, it's not invisible. It's invisible to the 6 and the 1 and the 6. So I have to go the other way. So the proton is creating exactly what the neutron is invisible, what's invisible to it. Yeah, so it's making essentially the neutron invisible in terms of its mass. So it only has mass in a direction. So this is sort of like the nature of velocity, would be the orientation of these two things. So you could argue that in nature they're just spinning around each other, that they're actively always wobbling or spinning to keep themselves from falling into each other. They could even just be going back and forth like this all the time. And that as long as they're doing that, there's no motion in the object. But as soon as they start to dampen, or as soon as that motion, that flipping, stops and they stop spinning, then they would have a directionality based on, just from the force of gravity itself. Because they'd be filtering the mix now in a specific way, where they would end up feeling it more from one side than they would feel it from the other side. So they would essentially, depending on how the protons and the neutrons are lined up, that would be the cause of velocity. So if the proton and the neutron stop wobbling and they set on a pattern, like say you do put a magnetic field in here, which reorients everything because it's pushing very specifically, very specific polarized photons. So the gravitons now are just polarized ones. Well, then it's going to tend to force the neutron above the proton, or the proton above the neutron, depending on what pole you're at. And it's going to tend to want to keep it there. It's going to tend to force it to stay in that orientation. And in that orientation, it's going to tend to move in a direction because of just it's going to be filtering more of the mix from this direction than from this direction. Being affected by more of the mix in a certain direction, and that would be the initiation of velocity. So you could sort of see the proton and the neutron as the regulator of speed, and that the more frigid they are, the more frozen in a position, the more likely the matter that those atoms, with depending on how many of them are frozen, the more likely it is that matter is moving in a direction, because these are going to keep tending to be pushed in this direction, and the electron will just trail along with it. And so obviously this is all happening, at a massive scale, trillions of interactions with all these little things hitting. So 1 second of of this cosmic activity, could be visualized as 10,000 years of human endeavor. All the actions of all the humans for 10,000 years might be 1 second of interactions inside of an atom. So it's, this is the problem, trying to model something on these scales, because the scale is so huge. Just like the big universe out there is so gigantic, it's, impossible to comprehend it, to rationally put it somewhere as a to orient yourself to the detail. There's so much detail. Yeah, it's like even a screen like this is, it's got 1,000,000 pixels, and you can't really understand it as 1,000,000 pixels. You kind of break it down into like 100 pixels. You kind of think of it as, okay, that's a blue dot, and that's a red dot, and that's a, but the depth, the density is a lot deeper than you think. And obviously, just even in reality, how many, the detail of of the pixels, it's really high. We just can't see them. They're right there, though. I mean, if we had better eyes, we could see them. If our eyes could just magnify like a microscope, and just zoom in, they're there. The pixels are there. We just don't have the tool to grab them, to conceptualize them. So anyway, so yeah, this was a lot of thinking that went into this, even though this doesn't look like much. It just creates the idea of this balance that exists between the electron and the proton. Yeah, certainly an atom could exist with just the proton or just the neutron as the nucleus. It could exist, but it wouldn't be as stable. It wouldn't, because it wouldn't have these forces that are, this just keeps it kind of rigid. The electron kind of is obliged to play along more because of that circumstance. But obviously, when you're exposing it to filtered material, that's when everything starts to distort, because everything's going to be affected differently by the filter, and so then you'll start to create funny shapes to the atom. Perhaps the neutron here, the proton will do as a solid, and then an exaggeration, because everything's sort of getting pushed into an orientation or an alignment just because of the wind, so to speak, being created by the polarized, I gotta find a symbol for polarization, gravitons coming in instead of the mixture. So when there's a mixture, everything can sort of just balance out, everybody's kind of relaxed, everything's okay. But as soon as you start filtering, then you start targeting the strengths and weaknesses, so to speak, of the players, and they start to tend to align to that wind. But again, on the real level, you have to remember that these are all schools of fish. I mean, a neutron is a school of fish, and a proton is a school of fish. Everything moving, lots of stuff going on in there, and that ultimately it's just the little fish that are getting affected in terms of a subtle imparting of influence. Like I said, all you're really saying is that there's this exchange of directional information. It's not an exchange of energy. It's just an exchange of direction. As stated, it doesn't matter to the fish which way they're going. They just don't care because it's all the same. There's the same pressure everywhere from their perspective, and so direction just doesn't mean anything. So they'll exchange it easily because it doesn't mean anything. Kind of an idea. It's not in the nature of their energy. Their energy is the fact that they're going from here to the next step. It doesn't matter whether the next step is this way, sideways, forward, backward. It just doesn't matter in terms of from their perspective. It's all the same depth of it's all the same thickness. They don't have something called momentum, in a sense. What? Yeah, well, sorry, you're not getting anything else. Anyway, so that's probably enough anyway. Cat interruption and whatnot. So, draft. Yeah, I don't know where to, I mean, I guess I got to play with electricity some more, but yeah, it's doing the nuclear model is just going to be, that's going to take, it's going to consume more time than it might be worth in terms of getting this overall idea of gravity being photons, gravitons, and getting the idea that it's all the whole universe is just made out of these discrete bits of quanta. I mean, that's the bigger theme idea. And within that theme is the idea that they, because of the circumstance of their association with each other, their forced encampment, they become capable of being influenced more and less by the other fish around them in terms of which direction they have. They will exchange directional information more freely or less freely, depending on arrangement, shapes, patterns that they're moving in. It's probably close enough. Alright, till next time. Such.